Hello, everyone. Since in Thursday class we didn't have the chance to go over 3.1 because of the noise that we were having in the classroom, so I'm gonna make this quick video to check with some of the main derivatives and some of the more interesting problems that this practice has. So, first than anything, doing derivatives at this point is not about anymore going with the limit, but to know how to apply certain formulas that you should know from your pre-class videos. So let's see some of those formulas and remember here. One of the main formulas is the formula for the power. So if we have that f of x is x to the n, then we have that the derivative is going to be n x to the n minus 1. So essentially, we are putting down the n, and then we'll subtract 1 from the n power here. Now, for the log of x, the derivative formula is going to be 1 over x. And if we have a constant, then the derivative of that constant is 0. If we have the function x, then the derivative of that formula is going to be 1. The trigonometric functions, they're related with the derivatives. So for example, in the function sine of x, the derivative is going to be cosine of x. And when we take cosine of x, we're going to have minus sine of x. So both cosine and cosine, they have a cross relationship with the other function. When we have the exponential here, the derivative of a function b to the x, it can be 2 to the x, phi to the x, e to the x, then is going to be the same function, which is b to the x, times the natural log of b. So in the particular case that we have e to the x, this is going to become log of e, which is 1. So that gives me the same function. So now that we're talking about powers, if f of x is just a function e to the x, then f prime will be, in this scenario, e to the x log of e. But then log of e is just going to be 1. So this is just going to be producing the function e to the x. So because of that, now if we have the function e to the kx, then this is just going to be the same function exponential to the kx, but multiplied by k. And again, here we have log of x, which is 1 over x. But if you have a log of a different basis, let's say log base b of x, then this is just going to be 1 over natural log of b times x. Okay, and so this is going to conclude all the basic derivatives. So let's now move to some of the drill practice problems. In here, we can mostly apply some of the big power functions and the algebra rules that we have per powers to get our derivative on the way. So we have some simple formulas. Of course, we have x. We already know that this is 1, but you might want to know why. Well, this is x to the 1, right? And so if we apply the derivative formula, that's just like putting 1, x to the 1 minus 1. And so that's just going to be x to the 0, right? And if you remember, x to the 0 is just 1. So this becomes fully 1, okay? Now, signs are not going to make a lot of influence in the derivative here, or constants overall that are multiplying our powers or derivative functions. So if we have this f of x equals minus x squared, then we're going to follow the derivative of x squared. The derivative of x squared is going to be, we put down the 2x to the 2 minus 1, which is 1. So we can leave it as 2x. And since we have a minus in front, then we can just leave it with the minus 2 in here. Now, same way, we have this 1/2 in here. And the only effect that it's going to have with this x cubed is that for the derivative, it's going to be multiplying. So it's going to be 3 times 1/2 x to the 3 minus 1. That will be the initial way to do this. And so simplifying this really quick, this is 3/2 x squared. Okay. Now at this point, you probably realize that a lot of this is just putting down the number that is in the exponent and subtracting 1 in the power. So we can just do that here. This is 4x to the 3. In the same way, this is going to be minus 15x to the 4. This is going to be 12x to the 5th, 7x to the 6th, and so on and so forth. A over 4 x to the 7 and 9x to the 8. Okay, so this one are not that bad. Now we can have some scenarios where we have negative exponents and they work exactly the same way. So here you have minus 4, and then what's going to happen with the derivative is that this minus 3 goes down here to multiply, and this is minus 3 minus 1. So as you can probably guess, this becomes a 12 x to the minus 4. Okay, and that's it. So not a lot of changes. We also can generalize the power rule to rational powers and rational exponents. So here you see x to the 1/2, which is the square root of x. Okay, and the way that this derivative works is the same. So we put out the 1/2 and we get x to the 1/2 minus 1. And then this is going to be 1/2 x to the minus 1/2. Okay. Now here there's an important rule that we discussed in the class, and hopefully you remember. But when you have x to the minus n, this is really 1 over x to the n. So in this scenario, if I have this x to the minus 1/2, this is just 1 over x to the 1/2. Be careful, but because this is not tied to the 1/2, so you should not move that 1/2 for anything. Now over here, then that's done. And at the end, if you want to, you can just write this as 1 over 2 square root of x. If you have decimals on your power, it's the same thing. There's not a lot of change in this. The derivative here will be 1.25 x to the 1.25 minus 1. And so that will be 1.25 x to the 0.25. All right. Here we have a negative exponent, so now you know what's happened with it and with the fractions. This is minus 1/2 x to the minus 1/2 minus 1. So minus 1/2 x to the minus 3/2. Okay. Now we move forward here, then this will be minus 5 over 3 x to the minus 1 minus 1 over 3 minus 1. Remember, minus 1 can be put in terms of the denominator here, which is going to be 3 over 3. So this becomes minus 4 over 3 when I complete the addition. Okay. Now this square root of x, this root of x to the 4 can be seen as x to the 1 over 4. And so if we create a derivative for this, this will be x to the 1/4, x to the 1/4 minus 1. And so simplifying this is 1 over 4 x2 minus 3 over 4. Since 1 is 4 over 4, 1 over 4 minus 4 over 4 will give me minus 3 over 4. And here we have a sum of powers, and what happens with this is that we can apply the derivative in each of the parts and make the sum. So in this scenario, we will have ax plus 3 plus 0, since we're applying power rule to each of the parts. In this scenario, it will be 0 and minus 10 x to the 9. Now we jump to some more elaborate derivatives. So in this part, we can see that we have a subtraction, but they play exactly with the same rules than when we have a sum of different powers. So for example, here we will have this is 33 x to the 2 minus 88 x and minus 0, because 1 becomes a 0. This t to the 2/3 means that we're using a different variable. That's the only thing. So we're taking a derivative with respect to t. So this will be 2/3 t to the 2/3 minus 1. And so that's just going to be t to the minus 1 over 3. Okay. Of course, in here, I am assuming that this is a function y of t equals this. Okay. Otherwise, if we have just a constant of any nature, if this will be if y will be a function of x, then this will be a constant, and the derivative will be 0. But for this scenario, we're assuming that this is a function of t. Now here, y is back to being a function of x, and we have that this derivative is cosine of x, which is the derivative of sine, and the derivative of the exponential is the exponential itself again. Here, again, we have another sum. This is just 10x minus 10x to the 4 plus 0, since phi becomes 0. The derivative of cosine of x is minus sine of x, and the derivative of x squared is 2x. So we add those up. The derivative of 4t, assuming this is a function of t, of course, y is a function of t, then this is 4 only, because t becomes 1 and 4 becomes 0. So this is 4 plus 0, 4. Now we have an exponential here, and remember that exponential are itself multiplied by the constant. Realize that I made a mistake before. Here we have 2 times 0.1x. Sorry. Let me erase this here. Okay, this is 2 times, and the derivative of the exponential is the exponential itself times 0.1, which is the constant here. Not 1 over 0.1, but 0.1. This is going to be square root of x, which, as we saw before, this is just 1 over 2 square root of x plus 1. 5 is 0, and so minus the derivative of sine is cosine of x. This is 1/2 f to 100. It doesn't matter if it's a big power. This is 100 divided by 2 is going to be 50, x to the 99 plus 0. 2 to the x, again, this is just 2 to the x times log of 2 plus, and then we have 2 over x. And so this is a little bit more complex. So let me go below and actually show you how to deal with that one. So we have 2 over x. We can see this as 1 over x. And we can see 1 over x as x to the minus 1 according to our rule of algebra. Okay. Now, finally, if I'm going to take derivative of this, so this is just y, right? Now, y prime is the derivative of this, so it's going to be 2 because that's not going to be affected. The minus goes in front, so minus 2. And so x to the minus 1, so minus 2. So this can be also expressed according to our rules as minus 2 over x squared. Okay, so we're using, remember, for this one, for this part, we're using the formula where x to the minus n is 1 over x to the n. And then here we're using the power rule for the derivative. So at this point, this becomes here minus 2 over x squared. And of course, we gotta fix this sign when we simplify. Now, this here is going to be 2 derivative of log over x is 1 over x, so 1 over x plus 0, so 2 over x essentially. And here we have a sum of 2 negative powers, so minus 6 x to the minus 7 minus 7 x to the minus 8. Now let's move to this one here. We have this exponential here. So again, this is going to be 100. The derivative of this exponential is itself, but it's going to pull out this 0.04 exponential to the 0.04t. 5 over x, same thing, 5 over x times log of 5, and this one is 0, and this one is x to the x minus 2, and this is minus 2x to the minus 3. This is e to the x minus twice e to the 2x, and this is 2x minus 1 over x. Nothing fancy here. This again, it becomes x to the minus 1. So since it's x to the minus 1, you can see that it's minus 1 over x squared. And derivative of cosine is minus sine. Now we have a bunch of different rational exponents here. This is going to be 1/2 x to the minus 1/2, subtracting really quick the 1, plus 1 over 3 x to the minus 2 over 3, and plus 1 over 4 x to the minus 3 over 4. In all these scenarios here, I already subtracted the minus 1 from the power for the derivative, so I'm just doing it really quick. So in this scenario, we have a ratio, but we don't know how to do ratios yet. So the easiest way that we can go about doing this derivative is just simplify that ratio. How do we do that? Well, we can split this in 2 pieces, and this is going to be x squared plus x. So finally, this is just, the derivative of this is just going to be 2x plus 1. And this is going to be minus 2x to the minus 3. Okay, and so that concludes the drill practice of these derivatives.